So this will be coming under example 11. Okay, example 11. I'll be giving the question. Okay, so from here onwards, the questions will be somewhat trickier. So what you have to do is you have to read the question. Okay, you have to read the question, and afterwards you have to answer. Okay, so you just write the question using z transform, using z transform. Okay, determine determine the response, determine the response y of n, y of n for n greater than or equal to 0. So they have given the n value, that is n is for all real values. Okay, if y of n, so they are giving the signal y of n signal as 1 by 2 y of n minus 1, okay, plus x of n. Okay, so okay, this is the one signal. Okay, so in this there is here what in this signal what you can infer is that y of n is your present state. Okay, y of n is your present state, y of n minus 1 is your past state. Okay, so your input, that is your output, depends upon the previous state of your input. Okay, okay. It's similar to your iterative process which you have studied in your M3 subject. Okay, iterative process you might have gone through. So over the iterative process, what you'll be doing is in Newton Raphson and all, you'll be taking your previous value for the output. Okay, similar to a closed loop system. In a closed loop system, your error will be minimized only when the output is again fed and compared to the input. Okay, so this system is passed, which contains a pass signal. Okay, so over here, this they have given some values. That is, they have determined the value for x of n. So x of n, so where x of n, they have defined x of n as 1 by 3 the whole power n, u of n into y of n. So where your u of n is nothing but your unit step function. So you already know. Apart from this, here they have given one. Again, they have given on your present state. Okay, here again they are giving your present state of your output. So this, don't you know about this? Again, they are giving some values for your y of for your y function. That is y of minus 1 is equal to 1. Y of minus 1 is equal to n. So you can hear me, right? Yeah. So here the given is y of n is equal to 1 by 2 y of n minus 1 plus x of n. Okay. So again x of n is equal to 1 by 3 the whole power n u of n into y of n. Okay. So again y of minus 1 is 1. So this is what they have given. So to find what they have to find z transform. Okay. So they have to find the z transform for this y of n. So how you can find? So solution. First you take down the signal. Okay. Y of n equal to 1 by 2 y of n minus 1 n minus 1. Okay. plus x of n, okay, plus x of n. So now what you have to do, you have to take your z transform, okay. So we are having both signals on both sides, so both sides are also covered with your signals, okay. So you have to take your z transform on both the sides, okay? So take z transform, take z transform on, take z transform on both sides, okay. Okay. So now what happens? We're taking z transform of both sides. So y of z will be equal to, okay, that 1 by 2 will be the same as such, okay. So that is y of n minus 1, that y of n minus 1, for that your z will be, you'll be taking a z of minus 1. So y of z, okay, y of z after this plus they have given an initial value, okay. So they have given an initial value. So for that initial value, what you can take is this, the initial value is y of minus 1. You take it down your initial value is y of minus 1, okay. Instead of constant you can take this as a value, y of minus 1 plus x of z. So now what happens, substitute the value of y of z minus 1, it will be equal to 1 by 2 z minus 1. So that is z transform plus your initial function. So y of z will be there. So this value becomes 1 by substituting, plus x of z, okay. So now you have to multiply your 1 by 2 inside, okay. Multiply your 1 by 2 inside, you will be getting 1 by 2 z power minus 1 y of z plus 1 by 2 plus x of z, okay. So from this what you can do, you can bring your y of z to the other side. So you will be getting y of z, and then you will be taking it common out. So 1 minus 1 by 2 into z power minus 1, okay. It will be equal to 1 by 2 plus x of z will be on this side, okay. So after this you keep it as a one step, so make it as a equation 1. So then again, if x of n, so x of n signal you have to take, so x of n is equal to, they have given 1 by 3 the whole power n, okay, 1 by 3 the whole power n into u of n, okay, into u of n, okay. Okay, after this you have written, right? So over here the question, there's a mistake, I think. And question, there's a mistake here, y of n won't be coming, okay. You just cancel it off, this y of n won't be coming. So this is what your x of n signal, and this we cancel out, okay. So now we have cancelled it, okay. So now the y of n won't be coming, okay. So for this, what you can take, if you are taking a your x of z means take zt, that is z transform, then x of z will be equal to summation n equal to 0 to infinity 1 by 3n 3 power n into z power minus n, okay. So for this it is a constant, it is a constant. So your Z transform if you are applying means your formula will be 1 by 1 minus 1 by 3 Z power minus 1. So it is the formula. Okay, this is the formula for your Z transform. Okay, so this you take it as a constant, and finally you will be getting the formula like this. Okay, now substitute this value. Okay, substitute this value over equation 1. That is, put 2 in 1, then we get then we get what will be getting x of z, y of z equal to 1 by 2 plus 1 by 1 minus 1 by 3 z power minus 1 by 1 minus 1 by 2 z power minus 1. Okay, so this is a common in denominator. It will be applicable for both the fractions in the numerator. So you have to take y of z is equal to 1 by 2 into 1 minus 1 by 2 the into z power minus 1 plus 1 by 1 minus 1 by 3 z power minus 1 into 1 minus 1 by 2 z power minus 1. Okay, so by taking proper LCM and bringing the z value to the above, we will be getting y of z is equal to z by 2 into z minus 1 by 2, okay, plus z square divided by z minus 1 by 3 into z minus 1 by 2. Okay. So now over here what you can see, you are again getting two signals of y of z. You are again getting two signals. So what you can do, you have to segregate this signal into two types. So take this one as y1 of z and take this two as y2 of z. Okay. After segregating, you have to find our aim is to find the inverse. Okay, that is our aim is to find the response for this y of z. Okay, that is, in our question they have given your y of n in terms of your past value plus another one input value. Okay, again what they have did was, okay, again what they did was they have given your input value in terms of your unit response. But what they are asking to find, they are asking to find the uh, response of y of n. That is, they are asking you to determine y of n in terms of your u of n. Okay. To find also, if you want means you just write it clear. Okay. So response for response. Okay. So that's what they are asking to find, but through your z transform they are asking to find. Okay. So y1 of z, you can keep it as such. Okay. For this you can take the inverse, no problem, because it is a constant. So 1 by 2 will be there. So here minus 1 by 2. So it will be z power minus 1 by 2 again, like that you can take it. But over here, if you are coming out means there's a square in the term, and it is of second order degree. Okay, this is second order degree. Then what you have to do? You have to go for your partial integration. Okay, so bring the z to the downward. So now what will be there? It will be z by z minus. So take pi z minus 1 by 3 into z minus 1 by 2. Okay. So now this value will be equal to a by z minus 1 by 3 plus b by z minus 1 by 2. Okay. So now you have to determine the value for a and b. So a will be equal to z minus 1 by 3 into z divided by, okay, so this will be there, so you have to take the LCM. So z minus 1 by 3 into z minus 1 by 2 over the z equal to, so you need a, okay, you have to eliminate your this value, that is d, you have to eliminate. So what will be putting, so this will be taking LCM, right? So if you're bringing that, it means so this value have to become 0, so you'll be putting z equal to 1 by 3 over here. So if you're putting z equal to 1 by 3 means what will happen, you'll be getting the value as 1 by 3, okay, z equal to 1 by 3 we are putting, so 1 by 3 divided by, so this z minus 1 by 3 and 1 by 3 gets cancelled out, okay. So it will be 1 by 3 divided by 1 by 3 minus 1 by 2, so it will be 1 by 3 by 2 minus 3 by 6, okay. So it will be 1 by 3 by minus 1 by 6, so it will be getting the answer as a equal to minus 2, we'll be getting the value for a equal to minus 2, okay. Now you have to find for b. B equal to z minus 1 by 2 into z by z minus 1 by 3 into z minus 1 by 2, okay. So now what you have to eliminate, you have to eliminate your a. So if you're taking LCM means, so a into z minus 1 by 2 it becomes, so you have to put z equal to 1 by 2, so this z minus 1 by 2 1 by 2 get cancelled out, so we'll be putting 1 by 2 divided by 1 by 2 minus of 1 by 3, you have to put 1 by 2 by 3 minus 2 by 6, you'll be getting 1 by 2 by 1 by 6, so you'll be getting a value of 3. So now you got y2 of z, y2 of z by z value, you just write it out, so it will be minus 2 by z minus 1 by 3, okay, plus 3 by z minus 1 by 2. So now you just bring this z over that side, you will be getting y2 of z equal to minus 2 z by z minus 1 by 3, okay, plus 3 z by z minus 1 by 2, okay. So this is your y2 of z, okay, and your y1 of z is z by 2 z minus 1 by 2 is the y1 of z. So this one you just how you can write, you can write this 1 by 2 into z by z minus 1 by 2. So now what happens, take inverse transform, okay, take inverse transform for all the three, all the two signals, okay, take inverse z transform, we will be getting y1 of n equal to z inverse of y1 of z, okay. We'll be getting 1 by 2 1 by 2 the whole power n into u of n, okay. So for your y2 of z, similarly it will be z inverse of y2 of z, so which will be contributing to minus 2 into 1 by 3 the whole power n u of n, okay, plus 3 into 1 by 2 the whole power n u of n, okay. So now you have to combine these two, okay. So your y of n will be equal to y1 of, so So here it is n, not z. Here it is n. Okay. It is the response, so it will be n. So y of n plus y2 of n. So we will be getting the value to be 1 by 2, 1 by 2 the whole power n, u of n minus 2 into 1 by 3 the whole power n, u of n plus 3 into 1 by 2 the whole power n, u of n. So this is what your response of your y of n. Okay. Next, a small problem with respect to your convolution. You just see this problem for just 2 minutes. We'll be getting back to the next problem. We will be moving to the next problem. So it is regarding based upon your this example 12. It is based upon your convolution property. Okay. So find x of n by convolution for so find x of n by convolution for x of z. They have given 1 minus 0.5 z minus 1, okay, into 1 plus 0.25 z or minus 1. Okay. So they have asked to find your convolution. Okay. So solution you can directly move on. So directly we are moving on to the solution. So first we write the signal x of z equal to 1 by 1 minus 0.5 z power minus 1 into 1 plus 0.25 z power minus 1. So here what you have to do is you have to separate the signal. Okay, again you have to separate the signal. Okay. So you take it as x1 of z into x2 of z. Okay. So now over here your x1 of z will be equal to 1 by 1 minus 0.5 z inverse. Okay. Again your x2 equal to x2 of z equal to 1 by 1 plus 0.25 25 Z inverse. Now what you have to do is you have to take inverse. Okay, take inverse 30. So you will be getting x1 of n is equal to 1 of n is equal to 0.5 the whole power n to u of n. Similarly, your x2 of n is equal to 0.25 the whole power n into u of n. So now what you have to do, you have to change this to be 1 by 2 the whole power n into u of n, comma x2 of n will be 1 by 4. Okay, 1 by 4 the whole power n into u of n. Okay. So now you have got the signals, okay, separately. Now what you have to do is you have to take the z of x of n will be equal to z x1 of n into x2 of n. Okay, this is the convolution property what you have seen in your properties lecture. Okay, so x1 of z into x2 of z. Okay. So regarding this convolution property we are taking means the z transform value will be z, that is you have to z of n, okay, will be equal to summation n equal to, sorry, not n, k equal to minus infinity to infinity x1 of k to x2 of n minus k. So this is what comes from your convolution property. Okay. See through this. This is your convolution property. So now we put the signals value. The signals value over here. So we'll be getting z be getting the value to be summation k equal to 0. So it is take from k to 0 to n. Okay. So that is similar to a periodic function. Okay. Now we apply the value 1 by 2 the whole power k into minus 1 by 4 the whole power n minus k. Okay. So in this the common term you can take out is 1 by 4 you can take out. Okay. So it will be minus 1 by 4 the whole power n. Okay. Summation k equal to 0 to n 1 by 2 the whole power k minus 1 by 4 the whole power minus k. So now minus 1 by 4 the whole power n be summation k equal to 0 to n 1 by 2 the whole power k by minus 4 1 by 4 the whole power k. So this will be minus 2, okay, on simplification, okay. So now your x of n will be equal to minus 1 by 4 the whole power n, okay, into minus 2 n plus 1 minus 1 by minus 3 into u of n. Okay, so you can further simplify as x of n equal to 2 by 3 1 by 2 the whole power n plus 1 by 3 minus 1 by 4 the n u of n. Okay. Okay. So this we can stop, I think, and tomorrow I can see about the convolution. Okay, will be with respect to the convolution. Okay, with respect to convolution, you can see the what is the linear convolution and your circular convolution. Okay, so from that also they are asking some questions. Okay, that also will be dealing with. So today's class we can wind it up. So more or less, Z transform I have covered a lot. Okay, from these are the models. Okay, apart from these models, they might not be asking any other kind of question. Okay, if you're solving these kind of problems itself, it's well and good, but you have to refresh your knowledge in your Z transform. Okay, it's a compulsory one to refresh your knowledge in your Z transform as well as your partial integration. Okay, so how and all will be